Hello and welcome to another video with Cloud Solutions Tech. In today's video, I'm going to dive into deploying a full operational EKS Elastic Kubernetes Services cluster using Terraform. If you are working in a cloud infrastructure or DevOps, you will know how important automation and infrastructure as a code are to manage resources efficiently. So I'll cover everything from creating the infrastructure, managing Terraform's remote state storage with S3 and DynamoDB, and deploying Kubernetes resources, and even setting up load balancers for simple application in the cluster. By the end of this video, you have a good understanding of how to deploy your own EKS cluster and why managing the remote state properly is crucial when working with infrastructure as a code. So before we dive into the code, let's talk about why this is important. When managing infrastructure, especially in production environment, we need to ensure that everything is automated, consistent, and secure. Terraform helps us to automate infrastructure provisioning, but to collaborate with teams and manage infrastructure changes across environment, we need a centralized and secure way to manage the state. That's where S3 and DynamoDB comes into play. So S3 helps store the Terraform state, while DynamoDB ensures that no two people are working on the same resources at the same time by locking the state file. On top of that, Amazon EKS simplifies running Kubernetes on AWS, and by automating the setup with Terraform, we make our infrastructure not only scalable but reproducible. So with that context in mind, let's move into the project. So the prerequisite for this project, you need to create an S3 bucket. So in my case, I have already created my S3 bucket. I'll be using this S3 bucket right here. And then you also need to enable versioning. This is important. So once you have your bucket set up, you are going to update your backend. I've already created my folder, which is prod, and inside of prod, I created another folder called EKS cluster. So you can see that right here. Next thing that you need to do is to add the state locking using DynamoDB. So for that, I've also created that already. So you need to create two tables. For the DynamoDB table, the important thing is the partition key. So this is the lock ID that we're using right here, and it's case sensitive. So make sure you are using the same thing for your partition key. So once your DynamoDB table is set up, you also update right here. So you put it in your backend as well. Alright, so that's the prerequisite. So let's go over the project. So the project structure will give you an idea of the files and resources that we'll be working with. So I have two directories that we're going to be working with. So let's quickly go over the file that we have in the first directory, EKS_cluster. So for the EKS cluster directory, let's go over the files one after the other. So the first file that we have here, we have the EKS Node Group private, and then we also have the EKS Node Group public right here. These two files configure the worker nodes, which is the node group for the EKS cluster, with one for public subnet and then the other for private subnet. So this ensures scalability and redundancy for your applications running in EKS. The next file we have right here, security groups EKS.tf. So this file defines the security groups for the EKS cluster, controlling the inbound and outbound traffic. So this file is crucial for securing communications between the control plane and the worker node. And then next, we have the AMI data source. So the AMI data source defines the data source to retrieve the Amazon machine image, the AMIs, for the EKS worker node. So this file dynamically fetches the AMI ID based on region, ensuring that your node runs on the latest Amazon Linux images. And then right here we have the EKS variables. So this file contains variables specific to the EKS cluster configuration, such as cluster name, version, and maybe like the node group details. So this helps in customizing the cluster for different environments or scaling needs. And then next right here, we have the EC2 Bastion variables.tf. So the EC2 Bastion variables.tf declares the variable used specifically for the EC2 Bastion host configuration, such as the instance type and then the AMI. It makes the Bastion configuration flexible and reusable across different environments. So right here we have the VPC auto.tf verse. We also have the EKS auto.tf verse, and then the EC2 Bastion auto.tf verse. So these three files that I've mentioned automatically provide values to variables specific to the VPC, EKS cluster, and the Bastion, the EC2 Bastion host. So they help keep environment specific setting outside the main code base for easier management. And then the next file right here, we have the EKS cluster.tf. So the EKS cluster.tf, this is the main configuration file for deploying the EKS cluster. So it contains the logic for defining the EKS cluster resources, including the control plane and the configuration and the networking setup. And then right here we have the EKS output.tf file. So the EKS output.tf file lists the output values for the EKS cluster, such as the cluster endpoints and the authentication details. So this is very useful for integrating the EKS cluster with other services or configuring kubectl for access. Another important file right here is the IAM role for EKS Node Group.tf. So this file defines the IAM role for the worker node, which is the node group, allowing them to interact with AWS services like EC2, S3, and CloudWatch. So this ensures your nodes have the correct permission to perform their functions. And then the IAM role for EKS cluster, so there are two different things. So we have the IAM role for the node group, and then we have the IAM role for EKS cluster. So for the IAM role for the EKS cluster defines the IAM rules and policies required for the EKS control plane to manage the Kubernetes resources. So this grants necessary permissions to the EKS cluster to operate securely and effectively. So this file is basically the Terraform configuration file to manage the elastic IP resources that we are going to be creating, are going to be using for this project. And next we have the VPC variables.tf. So the VPC variables.tf file contains the variables specific to the VPC configuration. So this helps in customizing the VPC CIDR block, the subnet allocation, the availability zones, and so on. So let's go to the VPC output.tf. So this file exposes the output of the VPC module, such as the subnet IDs, VPC IDs, and then the route table details. So this is useful when referencing these values in other parts of the infrastructure. So let's move to this right here, the EC2 Bastion provisioners. So the EC2 Bastion provisioner files, so this is the Terraform configuration files that provision an EC2 Bastion host in the AWS. That is what we're going to be using. So a Bastion host, which is a secure jump box server that allow access to other EC2 instance and resources within our VPC. So we are going to be using this right here to create the EC2 Bastion provisioners. And then the next file right here, we have the generic variables. So for the generic variables, this file stores general variables used throughout the project, such as region, instance types, and other reusable parameters. So this keeps your code clean. And then we have the EC2 Bastion output.tf. So the EC2 Bastion output.tf file lists the output values for the EC2 Bastion host, such as the instance ID, public IP, and other access details. So this allows you to easily retrieve and manage these values after deployment. And then we have this versions.tf file. This project that is the file that we use. So the versions.tf specifies the required version for the Terraform and the providers, ensuring the capability across environment. And this is critical to ensure that all the features and syntax used in this project are supported. So earlier on we looked at it. We used the same file to update our backend. So for the S3 and the DynamoDB table that we created, as you can see right here, so it's this same file that we use right here. So this is where we are declaring our version and providers, and right here we are adding the backend. So the Terraform.tf contains buildable values that Terraform will use during execution. So it makes your configuration dynamic and flexible, for different environments without hard-coding the values. So, and then we also have right here the local values.tf. So the local values.tf holds the local values specific, to the particular environment. So which helps in simplifying and shortening, repetitive code logic. So this is very useful for managing resources and organizing configuration more efficiently. And then right here we have the VPC module.tf. So the VPC module.tf defines the main VPC resource using the Terraform module. So it sets up the necessary networking infrastructure like the subnets, the route tables, the internet gateway, required by the EKS cluster. And then we have the EC2 Bastion security group.tf. So this file right here defines the security group for the EC2 Bastion host, allowing SSH access only from a specific IP range, and this also ensures that your EKS cluster is secure. So the EC2 Bastion instance.tf file defines the EC2 instance that will act as the Bastion host for securely accessing the EKS cluster. So this is very essential for administrative access, for your VPC, for your VPC's private resources. So with that, we have been able to cover all the files that we have in this first directory EKS cluster. So I'll make all this code available in our Git repository. So in case you want to test and try on your own, I'll make it available at the end of the video, so you have access to all the code. So let's go to the second directory. Let me clear my screen. So in this directory, we have these files right here. So let's also go over the files that we have here one after the other. So the first file we have here, which is the Kubernetes Deployment.tf. So the Kubernetes Deployment.tf defines Kubernetes deployment for running containerized application in the EKS cluster. So this file automates the process of scaling and managing ports within your cluster. And then the next file right here, which is the Kubernetes NodePort service.tf. So the Kubernetes NodePort service.tf defines the NodePort service to expose Kubernetes services on specific ports of worker nodes. So this allows external access to your applications running inside the cluster. And then right there we have the providers.tf. So the providers.tf specifies the required providers like AWS and Kubernetes that Terraform will use to deploy the resources. So ensuring the proper plugins and APIs, are being leveraged for the infrastructure creation. And then we also have the Kubernetes load balancer service, network load balancer.tf. So this file configures a network load balancer for Kubernetes service that requires high throughput and low latency. So this is ideal for distributing traffic to your services in a secure and high performance manner. The next one we also have here is the Kubernetes LB CLB.tf. So this file right here configures, we use this to configure a classic load balancer to distribute traffic across the Kubernetes services. So this is very useful for exposing services to external users. And then right here we have the remote state data source. So the remote state data source configures the remote state storage using S3 and DynamoDB for state locking and consistency. So this ensures that your infrastructure state is stored centrally and allowing for collaboration and preventing configuration drift. And then the last file that I have here is the version.tf file. So the version.tf file, similar to the previous version.tf file in the other file we looked at earlier on. So this one ensures the correct version of Terraform is used for Kubernetes resource deployment. So before I round up, let's quickly look at these two directories. The first one right here, which is the local exec output file. So this contains local execution files that are generated during the deployment process. So it's used to organize the output from the Terraform execution. That is all that is doing. And then this right here, the private key. So this stores, I created this private key in my EC2 instance, which is created right here, key pairs right here. So under key pair, you create your key pair right here, you store it locally. So I put my key inside of this directory right here. So this key that I've stored here is used to access the EC2 Bastion Host and other resources. So this is important, for secure access to your instances without hard coding sensitive information in the Terraform file. So that is why I put it inside of this directory right here. So at this point, we need to run Terraform. You need to initialize the project and download all necessary providers. So I'll say Terraform init. Alright, so Terraform init is successful. So Terraform has successfully initialized. So right here you can see that they downloaded all the modules that we need, like the VPC modules, the public module, the public Bastion. After downloading all the necessary modules, they initialized the backend. So the next thing now, let's go and run a Terraform validate. To validate our code. Alright, successful. So the configuration is valid. And then for me, I always like to run Terraform format to make sure the format that I've used, everything looks good. So if it does not return any output, it means that everything looks good. So now let's go ahead and run Terraform plan. So we'll use Terraform plan to review the changes that will be made. All right, so let's run Terraform plan. All right, as you can see here, we have 40 to add, 0 to change, 0 to destroy. So 40 resources will be created. So let's go ahead and run Terraform apply. So for the apply, I like to use Terraform apply auto approve. Right. So creating the resources now, this might take between 10 to 15 minutes. So I'll pause the video. Once the apply is done, I'll come back and continue. So as you can see, the EKS cluster is created, and it took about maybe roughly 15 minutes to create everything. You can see everything right there is created. So let's verify some of the things that we have done. So let's go to S3 bucket. Remember, we use S3 as our backend, and then our bucket we use this EKS cluster, and then this EKS cluster we can see this terraform.tf state file. And then also, if you want, you can go ahead and download the file to review it. So it's a JSON file, so you can go ahead and download the file. And then also remember, I made mention of enabling bucket versioning. So if you come to version right here, you can see versions of the bucket. This is the latest version, this is the current version, the one we just used. That's it right there. Next thing, now we have to go into the next directory for the Kubernetes Resources Terraform Backend configuration. So we're inside of the second directory now. So here we'll go ahead and run the Terraform commands. Okay, so now let's go ahead and run Terraform validate. Alright, Terraform validate looks good. And then run Terraform format as well. Alright, nothing to format. And then let's go ahead and run Terraform plan. So the Terraform plan is complete. So you can see right there, it's going to create 4 resources. So let's go ahead and run Terraform apply. So you can see our Terraform apply is complete. So we have the deployment, and then also 3 services, which are the load balancers that we have there, and then also the NodePort as well. So the next thing that we are going to do now, we are going to configure the kubeconfig for our kubectl client on our local desktop. So let me go back to my terminal. So I'll see the Terraform output. So what we need now is our cluster ID. Our cluster ID is right here. See, so we've been able to update that, so that looks good. I'll see kubectl nodes. So we can see we have 1 node right here. So I'll see kubectl nodes. So we can also run kubectl.svc. So this is providing for us from the default namespace services like my app1 load balancer service. You can see this right here as well, and then you can also see this as well. You can see that all the services, they are showing and they are running with their cluster IP as well. So the next thing for us now, let us verify our Kubernetes resources. So we'll run the kubectl again. So we say kubectl build ports, and we can find 2 ports running here. So now we can see we can access all these resources now. So we can, one thing that we can also do again, let's go to our EC2 and load balancer and verify if they are also if they were created as well. Let's quickly go and check our load balancer, and then we'll come back to the EC2. Alright, good. So right here we can see our two load balancers that are running as well. So you can see this one, it says active. So this one right there, this is the network load balancer. So we can access that, and this other one is our classic load balancer. And we go to the target instance right here, we can see our instance right there. You can see the status right there is in service. So both load balancer, we should be able to access them now. So what I'll do, I'll just copy the DNS name. Let's go to the browser. You can see it's successful. So let's copy the second one as well. It should be successful as well. The second one is also successful as well. So we can access both of them. So which means we're able to access our application that was deployed in Kubernetes cluster successfully. And then also another thing that we can also do, the node service port as well. Say kubectl get nodes. Alright, so with that, it's providing the external IP of our node as well. So we can see the external IP of our node right here. So we can copy that as well. So this one right here, this is the node for our public local node group right here. So let's go to the security. So we should have these two security groups and this IAM role that was created. So the one we want to look at is this one with EKS remote access security group. So we need to edit this security group. So let's start one. We are going to use custom TCP, and then we'll say 31280. And we'll say anywhere happy before. And we'll say the rules. And we'll say colon. So we'll provide the port right there as well, which is 31280. And then we're able to access it as well. So as you can see, we were able to test and verify our sample application in 3 different ways. So now that we are done with the verification of everything that we have created, so let's go ahead and do some cleanup. So the first thing, let's come back to this security group that we edited before. Let's go and remove that inbound role. Alright, let's remove this guy. Save. Alright, so let me go back into the other directory that I have our Kubernetes deployment and services. So we need to destroy that. So we say Terraform destroy So this should destroy all the Kubernetes resources, whatever we have created inside of the EKS cluster. So this is just the Kubernetes deployment, the Kubernetes node, the port services, the Kubernetes load balancers. So it will destroy everything. So let's get into the other directory. Alright, Terraform destroy. Let's get started. Alright, so Terraform destroy is complete. So let's also remove the .terraform folders. So we have been able to verify the cluster and the Kubernetes services, they're working. So we have also done the cleanup as well to destroy all the resources as well. So we have completed this project. So remember that once you are done as well You verify the cluster and the Kubernetes resources are working. You can proceed to clean up by removing any inbound roles that you have added into your security group for testing. It's important to maintain a clean and secure environment, especially if you are running in production. So don't forget to clean up your infrastructure once you are done by running the Terraform destroy, or you can run the Terraform destroy with -auto -approve the way I did it. So this would tear down all the resources that were created to avoid any unwanted cost. So thank you for watching. I hope this tutorial really helped you understand how to set up Amazon EKS using Terraform along with remote state management, Kubernetes deployment. So if you found this video helpful, make sure you like, comment, and subscribe for more tutorials on DevOps, cloud computing, and Linux administration. If you have any question, feel free to drop them in the comment section. I'll be happy to assist. So thanks for watching again. Make sure you hit the bell icon to stay updated with my latest tutorials. So coming up, I'll be diving deeper into Kubernetes, advanced Terraform configuration, and more cloud native projects. See you in the next video. Thank you.